Okay, in this video I'm going to be going over Module 12.1, Explain 1, which is on page 585. And it is writing explicit and recursive rules for arithmetic sequences. So I'm going to use the highlighter and I'm going to go through some of these definitions. So a sequence is an ordered list of numbers. Each number in the list is called a term of the sequence. You can think of a sequence as a function with a subset of integers as the domain and the set of terms of a sequence as the range. So if I'm looking down here, what they're talking about is the domain is the first term. So our first term is 0 and our y term is 0. Second term, so 2 is our domain, 7.5. Third term, 15. Fourth term, 22.5, and so forth. So it's a list of numbers. For the explicit rule, an explicit rule for a sequence defines the term in position n as a function of n. A recursive rule for the sequence defines the term in the position n by relating it to one or more previous terms. So I'll show you what that looks like. But first let's look at what an arithmetic sequence is. So an arithmetic sequence is also known as a discrete linear function, and it's a sequence for which consecutive terms have a common difference. So for instance, in this sequence here, we have the terms 0, 7.5, 15, 22.5, 30, and so forth, which all values of the function, and they're using b of s to represent it, have a common difference of 7.5. So if you look from 0 to 7.5, we add 7.5. From 7.5 to 15, you add 7.5. To get the next one, you add 7.5, you add 7.5, you add 7.5, you add 7.5. So the number in between, or the difference between each of these, is 7.5. So if we go down, it says you can write different explicit and recursive rules for a sequence depending on what integer you use as the position number for the initial term of the sequence. So most commonly used as a starting point are the numbers 0 and 1. So usually we start with the 0th term or the first term. And the table shows the rule for the sequence explained in the Explore. So we didn't go over the Explore in this video, but let's just talk about what this is. So for our explicit rule, here's the formula that you're going to need to know. In fact, I'm going to go ahead and highlight that in green. So this formula you do need to know. You do need to memorize it. You need to know how to plug numbers into it, and we'll do a couple examples of that. So for the explicit rule, this is what we have. For the recursive rule, we have this here. And so I'm just going to go ahead and skip this chart and go down to this explain and do it with you guys so that you guys are part of the process of developing it and it makes sense to you. So in the explicit rule, if we look at this, we have an equals, oh, they're using f of n. Let's go ahead and use f of n, sorry. F of n equals a plus d times n. And it does define what a is. So a is the initial term. So what is the initial term of your function? What's the first one we see in this sequence? Well, we see 2, 5, 8, 3, 11, 14, and 17, right? So the first one we see is 2. Okay, and it says for an arithmetic sequence, there's a common difference of d. So d is the common difference. So what is it that we're adding each time or subtracting each time to get to the next term? So from 2 to 5, I know I add 3. From 5 to 8, I add 3, add 3, add 3, add 3. So there is a common difference, and that common difference is 3. So I plug that in for d. And I have n, where n is the term. So think about this. If I wanted to find my third term, I could plug in 3 here, and I would get f of 3 equals 2 plus 3 times 3, which is 9 plus 2. So my third term is 11. Hey, that's true. If I wanted to find my 8th term, I would plug in 8 and try to find my 8th term, which is not quite what we're at yet, but that is something we will eventually do. So right now we're just going over how to write the rule. And so make sure you memorize this formula here and that you know A represents the first term and D represents the common difference. Now, what about a recursive rule? Because so far we've only done the explicit. What's the recursive rule? So if I write the recursive rule, I have f of 0 equals A, and f sub n equals f n minus 1 plus d. So this is the rule that we highlighted in green up here. So let's go ahead and fill this in. So to write this, I have my initial term, which we said was 2. So f of 0, my 0th term is, let's write it here, f of 0 equals 2. And now to find my f of n, I take f of n, I take my previous term, and what do I do each time? What am I adding? Well, we said the common difference was 3. So this is my recursive rule, which they have down here, right? So our recursive rule just says, let's say I wanted to find f sub 4. I wanted to find my 4th term. I would plug it into my formula, f of 4 minus 1 plus 3. And so I have f 4 equals f of 3 plus 3, which means I need to know what f3 is. I need that previous term in order to plug that in here. Well, what is f of 3? Well, we have this handy dandy chart for us, so we can kind of use that and say, hey, f of 3 is 11, and we add 3, we add our common difference in order to get our next term, which is 14. So that's why it's so important that you have a previous term. Okay, you have to have a previous term in order to find all the rest of the terms. So I'm going to go on to example B on the next page. And we're going to look at this. So again, we're finding the explicit rule and the recursive rule. So it says check the common differences. And so what they're doing is they're taking this term, the second term, and subtracting the first term to see what you added or what you subtracted here. Like this is simple enough to where we could say, okay, you subtracted 4 here, you subtracted 4 here, you subtracted 4 here, you subtracted 4 here, you subtracted 4 here. They're just showing you the work for that. Okay, so 25 minus 29 is negative 4. 21 minus 25 is negative 4. 17 minus 21 is negative 4. 13 minus 17 is negative 4, and negative 4. So we kind of already knew that by looking at the chart and saying that your common difference, well, is the same, so it is arithmetic. And we know that our common difference is subtracting 4. So the initial term, A, so what's our first term? Let's see, 29. The initial term A in the sequence is 29. The position number, notice on this sequence they start with 1, so the position number is 1. As already observed, the common difference we found to be negative 4. And as far as your explicit rule, now you just have to plug it into your explicit rule. Right above it, I'm going to write what we have memorized as our formula, which is A plus D times N. So now we're just going to plug in the information we know. We know A is 29. We know our common difference is negative 4, and N is our variable. So in this, what are the n values? We go from 1, not 0, like the last one, to 6. Now, for the recursive rule, remember our recursive rule is always f sub n, or f of n, equals f of n minus 1 plus your common difference. But you have to have, remember with the recursive rule, you have to have the second part. You have to have what your initial term is. And so what is our initial term? Our initial term is f of 1 equals 29. Our first term is 29. And then plugging in your common difference here. And then for what? For when n is from 1 to 6. So our two rules are here and here. Notice that I highlighted the f sub 1 equals 29. With recursive, you have to have both parts, the previous term or the starting point, and your formula for the recursive. So for your turn 3 and 4, I just want to get you guys started in the sense that I'm going to write the formulas for you. So for explicit, remember you have to memorize this formula. F of n equals a plus d times n. And for recursive, you have your first term, and sometimes this is f sub 0 or f sub 1, remember, is a being your first term. And then we have f sub n equals the previous term, which is n minus 1, plus your common difference. So you're going to want to go ahead and identify what is your first term and what is your common difference and plug that in. Same thing here. What is your first term and what is your common difference? So you're looking for the same two pieces of information in order to plug these in into the formula and to be able to find these. So good luck, guys.